All right, so we are starting 1.1 day 2 notes, which is still functions. In these notes, we're going to evaluate piecewise functions, and we'll also learn what the difference quotient is. So go ahead, pause the video, try the opener on your own real quick. You're writing the domain of each function. Remember to ask yourself the question of, is there anything x can't be? So pause the video, try it. All right, here are your answers. There are no restrictions on A, so your answer is all real numbers. Your domain is all real numbers. Next one, there is a restriction here. Denominators cannot be 0. So x can't be -2. So that would be negative infinity to -2, union -2 to infinity. Next one, you have a square root. Square root, the argument has to be greater than or equal to 0. So x has to be greater than or equal to -1. So we have bracket -1 comma infinity. Okay. Last one. Looking at the graph, it goes from an arrow and then it stops at the asymptote. So -infinity to the asymptote, which is 3, union, and then the asymptote forever. So those are your 3 domains. If you didn't get one of those, you can pause the video, jump back onto the Zoom, and ask your teacher to explain it to you. Okay, next, evaluating piecewise functions. This is super easy. You guys did do this in Algebra 2 with trig. So just a reminder is what a piecewise function is. It's a function that's defined using 2 or more equations from different intervals. So all separately, they are their own function. They would be a function if it wasn't a part of a piecewise. So this is just a parabola. This is the line y equals 7. This is the line y equals x minus 2. So you have 3 functions that are separate, but you're taking pieces of them to combine them to make one function. Okay. So realize it's 3 separate equations right here that you could be looking at. Y equals 2x squared plus 1, y equals 7, y equals x minus 2. It says, for the piecewise function given, evaluate each. So this first part here says find f of -1. Okay? Remember that means plug in -1. But you have to know where to plug it in. Okay? So what you're going to use is you're going to use the domains to tell you which one you're plugging it into. Because the first function is only graphed and only evaluated when x values are less than or equal to 2. The second one is only where x is equal to 5, and the third one is only for x values greater than 5. So since -1 is less than or equal to 2, you're going to plug it into this equation. So if I numbered them 1, 2, 3, that's how I can refer to them in the future. All right, so I'm going to plug it into equation number 1. So I'm going to do f of -1 is equal to 2 times -1 squared plus 1. So that's 2. Oh, sorry, that's 1. 1 times 2 is 2 plus 1 is 3. So f of -1 is 3. Okay, so you can pause the video and try the next 2 on your own and see how you did. Okay, so f of 5. So if I look at my domains here, this is when it is 5, I plug it into this equation. So I go to plug in 5 for x, and I get an automatic output of 7, no matter what. This one right here, f of 6. Look at which one I'm plugging it into. 6 is greater than 5, so I'm plugging into equation number 3. So I'm plugging in 6 into that. So I'm going to do 6 minus 2, which is 4. So f of 6 is 4. Okay, next is writing a piecewise function. So this is a real-life example of a piecewise function. It says a store charges $15 per shirt for orders 50 or fewer, $13.50 for t-shirt orders of 75 or fewer. But if there's more than 50 shirts, they charge $12.50 per shirt. Oh, wait, I read it wrong. And $12.50 per shirt orders of more than 75. Oh, okay, I read it wrong. So $13.50 for 75 or fewer, but more than 50. And then $12.50 for orders more than 75. Write a function that represents the printing cost C for X number of shirts. Okay, so first off, if you look at a piecewise function, I'm going to erase all these things that I highlighted and stuff. When you look at a piecewise function, it always starts with f of x or whatever it's called, g of x, q of x, r of x, and then the equal sign, and then the equations are grouped together. Okay, so This one says that it's cost C, so we're going to say C of X is equal to, and then remember the shirt can cost either $15, $13.50, or $12.50, so there's going to be 3 equations, so I'm going to leave enough room for 3 expressions on this side because it's together they make 3 equations. Okay. A store charges $15 per shirt on orders of 50. So we don't know how many shirts can be ordered, so that's X. So number of t-shirts is going to be X. So $15 per t-shirt if, and then it says orders of 50 or fewer. So that's if this X value right here is less than or equal to 50. Now before I write X is less than or equal to 50, let me ask you this question really quickly. Can I order -6 shirts? No. So I want to say, technically, I want to say that it's in between 0 and 50. So I'll say in between 0 and 50. Okay, I guess someone can buy 0 shirts, so we'll include that too. Okay, next, it's $13.50 per shirt if for orders 75 or fewer but more than 50. So in between 50 and 75. So remember to write that. You write in between 50 and 75. So greater than 50, less than 75. Now let's see if I need or equal to signs on any of this. So orders of 75 or fewer but more than 50. So 75 or fewer would be including 75, but more than 50 would not be 50, be like 51. All right, last one, $12.50 per shirt. If, and then this one is more than 75. So that is X is greater than or equal to 75. So what you should notice here is that in piecewise functions, we do use inequalities. That's the only time I think we ever use inequalities is in piecewise functions. So there's your piecewise function. All right, last topic that we have to talk about today is the difference quotient. The difference quotient computes the slope of the secant line through 2 points on the graph of a function. The slope of a secant line is very important in calculus, where it's used to define the derivative of a function. Okay, so we're going to talk about slope of a secant line right now. So first off, to remind you from geometry what a secant line is, a secant line is a line that intersects a curve or a circle more than once. Okay, so what I'm going to do is I'm going to put 2 points on this graph somewhere. I should probably change my color so it doesn't match this. Let's say that there's a point here and a point here. Okay, so I'm picking 2 points on this curve. So if I wanted to find the slope of the line going through these 2 points right here, okay, so that is a secant line. And I could have picked any 2 points anywhere, okay? So before I give you the formula, first off, if I want to find the slope of this line that I drew right here, I would have to know how far over this point is. So we're going to say this point is over A, right? I also have to know how far that point is down, right? Up or down, depending on where it is. Ours is down that I picked. And that we would call Y usually. We'd call it X comma Y, but I'm going to say that it's F of A, because all you have to do to figure out what it is I have to plug A into the equation, whatever it is, the function F. So that's this first point right here. So I'm going to move that over. It's right there. Okay. All right, so that means that this distance right here is A. Okay, what if I told you that this distance right here from here to here is H? Okay, if I told you that distance is H and I wanted to say, well, how far over is this point? It is A and then H more. So this is A plus H. And then to figure out what the Y value is, you just have to plug in A plus H. So F of A plus H. Okay. All right, so if I wanted to find the slope of the line, now I can use the slope formula. Remember, slope formula is the change in y over the change in x, or y2 minus y1 over x2 minus x1. So the slope, the change in y over the change in x, is equal to, so remember you're going to do y2, or y2, f of a plus h, minus y1, y1 is f of a, all over excuse me, x2 a plus h minus x1, which is a. So if I look at this right now, if I ask you if there's anything I can clean up, I can clean up the denominator because I know a minus a is 0. They cancel out. So the difference quotient, when all is said and done, is f of a plus h minus f of a all over h. So this right here is the difference quotient. Okay, it doesn't have a funny name. This is a great name for this. Difference, voila, quotient, voila, right? Okay, so on these next, let's see, how many are there? 4, I think? 5. 5 problems here. This says find f of a plus h, and then find the difference quotient. Find f of a plus h minus f of a all over h, okay? I like to start with example B, okay? Because example A is so easy that people are like, what? What just happened? So we're going to start with example B, okay? So we're going to start by finding f of A, right? Because that's what it asks us to find, f of A. F of A is, remember what this means. It means plug in A. So I'm going to plug in A to this equation for x. So I get 2a plus 1. That's done. Okay. The next thing it asks us to find is f of a plus h. So now we're going to find f of a plus h. Remember what this means. It means plug in a plus h for x. So I'm going to plug in, instead of putting x right here, I'm going to plug in a plus h. So I have 2, plugging in a plus h, and then plus 1. You're going to clean this up by distributing, and you get 2a plus 2h plus 1. So that is, watch that, so I don't have to rewrite f of a plus h. That is f of a plus h. Last, you're going to find the difference quotient. Okay, so remember what the difference quotient is. I'm going to write it again just so we can see it. It's taking f of a plus h, subtracting f of a, and then dividing it by h. Okay, so let's see what we get here. So we're going to take f of a plus h. Oh, my 1 kind of blended into there. I don't like that. There's a 1 right there. Okay, so we're going to take a plus h, f of a plus h, which is 2a plus h plus 1. 2a plus 2h plus 1. And then we are going to, so that's one function. We're going to subtract f of a, it says. So subtract f of a. So f of a, f of a. F of a plus h, f of a plus h. Just to color code it to help you out there. All right, and you should get 2a plus 1. Okay, you're going to put that in brackets for a second. You could use parentheses. I just think brackets just are a little bit cleaner. And then it's all over h. All right, now you have to clean this up. Okay, so what you're going to have to do is you're going to have to subtract this and subtract this. So I look at it as distributing the negative, right? So this becomes minus 2a minus 1. Now I can combine like terms in the numerator. I have 2a and negative 2a. I have a 1 and a negative 1. So here's something that you should know. If you're doing this correctly, anything in this second bracket will always cancel out with its opposite that's in the first. Okay? All right, so now all that we have is 2h over h. And now I can simplify this because I have 2 times h over h, so it's a factor, and I can cancel out this common factor, and it's 2. Okay? So we get f of a plus h minus f of h, minus f of a all over h is 2. All right, so let's go back to the first one and do that one. So I have f of a. So I'm going to plug in a into my equation here. I'm going to my expression. I'm going to plug it in for x. There is no x. I get an automatic output of 2. Now we're going to do f of a plus h. So now we're going to plug in a plus h for x. Once again, there is no x. We get an automatic output of 2. Now we're going to do f of a plus h minus f of a all over h. So f of a plus h minus f of a all over h. All right, f of a plus h is 2 minus f of a plus h, or sorry, f of a is 2 all over h. So we have 0 divided by h, right? Recall 0 divided by anything is 0. So now we know f of a plus the difference quotient, instead of me saying it all out, is 0. Okay, next one right here. We're going to do C together, and then you're going to try D on your own, okay? All right, so I'm going to start with f of a. F of a, so plug in a for x. You get a squared minus 2. F of a plus h. So I'm plugging in a plus h right here. So I have a plus h quantity squared minus 2. And I do need to expand this. Okay, so remember, a plus h squared, there's no such thing as distributing a square. Okay, distributing an exponent, there's no such thing. So if I asked you, sidebar conversation real quick, 4 squared is the shortcut of writing what? It's the shortcut of writing 4 times 4. Okay, so a plus h squared is the shortcut of writing a plus h times a plus h. Now you can FOIL a plus h times a plus h. A times a is a squared. Outer is 2ah, or sorry, outer is ah. Inner is ah. So together that is 2ah. Last is h squared. And then there's that minus 2 on the end. So pro tip here, memorize that a plus h quantity squared. So this right here is a squared plus 2ah plus h squared, because you're going to use it a lot. Okay, so let me box this here so we can see what this is. Ready? Watch that. Okay, so there is so far f of a and f of a plus h. Now I'm going to do the difference quotient. So I'm just going to put equals for now, just to, instead of keep writing that out. So I need f of a plus h, which is a squared plus 2ah plus h squared minus 2. Remember, I'm going to put this function in brackets, minus my next function, which is f of a squared minus 2, all over h. Now I have to clean it up, okay? So first part of cleaning up is distributing your negative. So I'm going to say this becomes plus, and then I'm going to bring my negative to each of these. So that becomes a minus, this becomes a plus. Now I'm going to go through and combine like terms. I have a positive 2 and a negative 2, a negative a squared and a positive a squared. So now I have 2ah plus h squared all over h. Okay, so the whole goal of this is that you are always going to be able, or not, I shouldn't say the whole goal, but something else you need to know is that you're always going to be able to cancel out the h in the denominator. But in order to simplify a fraction, remember you have to cancel out common factors. So if you look at your numerator, they do have an h in common, so you're going to factor out the h. That's 2a plus h, all divided by h. And then you can cancel the h's out, this h and this h. This step that I just showed, you cannot skip it. I cannot come back to this step and go boom, boom, boom. That is not allowed, okay? So please make sure you show the step that I just showed. And you're left with 2a plus h, and that's the difference quotient, okay? So that's this. Okay, go ahead and pause the video and try D, and then you can come back and check your work with mine. I'm going to do it really quickly. Okay, f of a is a squared plus 2a plus 3. F of a plus h. I'm plugging in a plus h here and here, so make sure you're plugging into both spots. So you have h plus h squared plus 2 times a plus h plus 3. All right, remember you have to expand this. This is a squared plus 2AH plus H squared. And then distribute your 2 plus 2A plus 2H plus 3. So here is f of A plus H. All right, now I'm going to do the difference quotient, which once again was f of A plus H minus f of A all over H. Okay, so I'm just going to copy and paste this if I can. Let's see technology work with me. Copy. Paste. Close enough, right? Good. That was life-changing right there, people. All right, so there's my first function, f of A. Oh, no. F of A plus H. Come on, I just want to move you over a little bit. There you go. Put it in brackets. Minus f of A, so A squared plus 2A plus 3. All over, I'll put that in brackets. All over H. Okay, clean this up. So I'm going to distribute the negatives. So this becomes plus, minus, minus, minus. Combine like terms. So negative 3 and positive 3. Negative 2A and positive 2A. Negative A squared and positive A squared. All right, now I'm going to write down what I have left. So I have 2AH plus H squared plus 2H all over H. Remember this next step you cannot skip. Factor the H out of the numerator. So you have 2A plus H plus 2 all over H. And now you can cancel out your H's. So your final answer is 2A plus H plus 2. Okay. All right, the very last one. F of A, plug in A for X. F of A plus H. Plug in A plus H for X. There's nothing you can simplify there, just so we realize it. And then finally the difference quotient, F of A plus H minus F of A all over H. F of A plus H is the square root of A plus H minus 1 minus F of A, the square root of A minus 1 all over H. This we cannot simplify. We're just going to leave it the way that it is, or we are not going to simplify, I should say. And we're going to leave it the way it is. So there's your notes for today. If you have questions, please pop back into the Zoom, talk to your teacher, or email your teacher if you're not in class right now so that you can have conversations. But what I want you to know is that this part off to the left right here, all this stuff to the left, this is just so that you can do the stuff to the right. So we're finding F of A and F of A plus H so that this we can jump right into, okay? All right, go ahead and start the homework. And